So now we're going to talk about how to factor sum of cubes and difference of cubes. And we already went through the pattern. The pattern is the clue. The pattern is what we want to pay attention to, because if we know the pattern, then that's going to make this process a lot easier for us, okay? So let's talk about how to factor first. So we'll fill in our notes here. So in order to be able to factor, we have to find the cubed root. Okay, we have to find the cubed root of each term. So finding the cubed root is a little tricky, okay? You could do some of these. I'm not going to give you any that are huge, okay? You could make yourself a list if you wanted to. You could do 2 times 2 times 2 is 8, and you would know that 8 is a cube. Then you could do 3 times 3 times 3 is 27, so you know that 27 is a cube. And then so on, and you could just do it probably up to about, I would say maybe, or do it to the 9, maybe, because 9 times 9 times 9 would be one of the ones that you would want to do, okay? So you could do it that way, okay? And make yourself a list, and then you could just have that list nearby. Oops, sorry. Then you would have that list nearby you at all times, and that would help you do it. Or you could just use a calculator. So I'm going to show you how to find the cubed root on a calculator. So what I'm going to do here is temporarily, I'm going to upload a picture of a calculator. Yeah, here we go. Whoa, a little big. Let's see if I can make it smaller. Now again, I'm not going to be able to tell you what the calculator is going to, I'm not going to be able to show you what the calculator is going to show you, because this isn't a live calculator. This is just a photo of one that I got off the internet, okay? So if you have a cubed root and you're trying to find, so let's say for example that you know that what they have presented you with is a cube, okay? Let's say that it is, let me think for a minute. Let's do 216, okay? 216 is a cube. You may not know that. So what you're going to do is now you probably are aware of the fact that this button right here means the square root. And it's the second function of the x squared button. So if you were just trying to find the square of something, you would do second, and you would push this, and you would find the square root of a number. But this is not a square, this is a cubed root. Now we're going to do a bunch more with other roots. We're going to do cubed roots, fourth roots, fifth roots, sixth roots. We're going to do that later in this semester, okay? But for the purposes of us being able to find the cubed root of 216, we would push this button math. And when we push the math button, what you're going to see up here is a list of things that you can calculate, okay? And one of them is going to look something like this. And what that is telling you is you want to find the cubic root of something, or the cubed root. So when you hit that button, then on the screen, this should pop up, okay? And at that point, you would type in 216 and push equals. And when you do that, it'll tell you what the cubed root of 216 is, which the cubed root of 216 is 6, okay? But again, you don't have to memorize these. You probably will know them before long, but that is a cubed root. So you push math, and then you select the one that looks like a 3, a little tiny 3 in front of the square root symbol. And then once you click that, it'll pop up, or press that, it'll pop up on the screen, and then you can type in 216. Okay, or whatever number you're trying to find a cubed root for. It may not be a cubed root. If it's not a cubed root, then it's going to give you a decimal, okay? All right, so we find the cubed root of something, okay? And we're going to fill in those values for the value of A and B in our pattern. And then after we do that, we can simplify anything we need to simplify. And I'll show you what I mean by that, okay? So let's do an example of factoring with both a sum of cubes and a difference of cubes, okay? So if we're looking at these two examples here, okay, so in this one, we know this is an addition sign, and we know these are cubed numbers, okay? 8 is kind of easy, okay? So the cubed root of 8 is 2. This one you probably could pick up on. It ends in a 5 because 5 is the cubed root of 125. So here's what I'm going to write. I'm going to write, and you could have used your calculator if you needed to. I'm going to write that A equals 8. Oh, sorry. A equals 2, right? Because that's the cubed root. And B equals 5. And I'm going to write my pattern. Here's my pattern. And the more you write it, the easier this will become. A squared minus AB plus B squared. And every time I see a variable, I'm going to fill it in with this. So I'm going to write in here for A, I'm going to fill in a 2, and it's going to be 2x, okay? This is x cubed right here, okay? So basically then, if I fill this in, I'll tell you what, let me do it this way. Before I get to that step, let me do it this way. What was cubed? You know what, I can leave it that way, I guess. Let's leave the pattern, sorry, indecisive. Trying to make sure I find the best way to explain it. So let's plug in those values. So for A, I'm going to put in 2, but remember it's 2x, because you didn't just cube 2, you probably should write that. We cubed 2x. So let's write, instead of A, we'll write 2x. Instead of B, we're going to fill in a 5. And then for A squared, I'm going to do 2x squared, right? Because A value is 2x, and I got to square 2x. And then minus, and then I have to do A times B. So 2x times 5. And then the last one is to do 5 squared. So when I simplify, that just means any of these things that can simplify, that second one really is the only one that you're going to have to simplify. 2x squared means to square 2 and to square x. So if I square 2, I get 4, and if I square x, I get x squared. And then if I do 2x times 5, that's going to give me 10x, and then 5 squared is 25. So this is how this sum of cubes factors. This is the factored form of that polynomial, okay? But we got to that point by following the steps and following the pattern. So now let's do the difference of cubes. Same idea, just a different pattern, okay? So I gotta find the cubed root of 216, but that also happens to be the one we just tried a minute ago. So I know that that is 6, and then it's an x. And then the cubed root of 1, anytime you do any root of 1, it's still 1, okay? So that's gonna be a 1. So now let's fill it into our difference of cubes patterns. Difference of cube pattern has a minus 5. Or I'm sorry, a minus b. And then the rest of them in the trinomial is all positives. So let's fill them in. Just fill them in with what we've got. So instead of a, I'm going to put 6x. Instead of b, I'm going to put 1. And then over here, a squared means I'm squaring 6x. And you want to make sure you put parentheses. It kind of looks like double parentheses. But you want to make sure you do that so you know that you are actually squaring not just the x. That's probably the most common mistake I see, is that everybody wants to just put 6x squared, and they forget to square the 6 because they think of it as one unit. But it's not. Okay, the 6 gets squared also. And then the a is 6x, and the b is 1. So I'm going to put them together side by side because I'll be multiplying those. And then the b squared is just 1 squared, which that's going to be really easy, but we'll write it out anyway. So if I simplify, 6x squared means to square the 6, which is 36, and the x squared, plus 6x times 1 is just plain old 6x, and then 1 squared is just 1. So this is how this difference of cubes factors. So this is the factored form of this, okay? Now I could continue and I could try to solve these or see if anything factors further, okay? But it's probably going to be more difficult for us to figure that out. But they would factor, and you could continue. And we'll do some of that in the next examples where we actually factor them, and then after we factor them, then we actually solve them by finding the zeros of this function, which means we might have to factor this further. And if it doesn't, we might have to use quadratic formula to find the zeros or the values or the solutions for x.